Now we're going to talk about how uphill and downhill angles and environmental conditions affect your impact downrange. When I'm talking about a rifle that shoots flat or a rifle that has more drop, this is what I'm talking about. The rifle on the top diagram here, would be considered a flatter shooting rifle than the rifle in the bottom diagram. The rifle in the bottom diagram has more drop. It could be that the rifle in the top diagram maybe is a bigger caliber rifle, maybe it has better ammunition, but all things being equal, the rifle that shoots flatter is going to be a better rifle for long range shooting. Okay, what you need to know about shooting downhill or at a downward inclination angle is that you're always going to hit the target higher. Your impact is going to be higher on the target when you're shooting downhill than what it would normally be when you're shooting across a flat plane. And you can see why that happens with this diagram. If you look at the rifle on the top shooting across a flat plane there, you can see how the gravity applies across the entire distance. But for the rifle on the bottom diagram, you can see how the gravity only applies on your bullet for just one component of the distance. It's not as long of a distance that the gravity is applying on your bullet when you're shooting downhill. So your bullet is always going to hit high. Okay, now this shows what happens when you're shooting at an upward inclination angle and you have the same effect. The gravity is only pulling down on your bullet for one component of that distance. It's not pulling down on your bullet for the entire distance. So once again, your bullet is going to impact the target higher than normal. Okay, this is what your chart looks like. And let me just say this about your chart. There's a lot of great formulas on this chart, a lot of helpful information, but if you don't understand how to apply the formulas, just like in any other endeavor, it's not going to work out for you very well. You have to understand what causes these changes to the flight of your bullet as it's traveling downrange. Okay, so how do you adjust for shooting at a downhill angle or an upward angle, at an inclination angle? Well, I gave you a little cheat sheet with this chart. If you look at the 700 yard marker there, the horizontal line that designates where you need to hold to hit your target at 700 yards. If you look above there, in between the 700 yard mark and the 600 yard mark, close to the 600 yard mark, you're going to see an extra line in there that says 700 at 30-degree angle. That's where you would need to hold if you were aiming downhill or uphill, either one. It's going to be about the same amount of difference there, but that's where you would need to hold to adjust for aiming downhill at a 30-degree angle if you were trying to hit your target at 700 yards. Okay, so I added some imaginary red lines in here. Each of these red lines designates where you would need to hold if you were aiming downhill or uphill at a 30-degree angle at each of these yardages. So if you look at the red line in between the 600 and 500 yard mark, that is where you would need to hold if your target was at 600 yards and you were aiming downhill at a 30-degree angle. Same thing for the line above, and then the line at the top, the red line at the top, that's your mark where you would need to aim at 400 yards if you were aiming downhill at 30 degrees or uphill at 30 degrees. Either way. So you can see, actually, one thing I want you to notice is if you look at the angle marker for 30-degree angle for 700 yards, the one down at the bottom there, you'll notice that that line is relatively pretty close to 600 yards. Looks to me about 620 yards, maybe 625. If you look at the marker that designates your 30-degree angle for 400 yards, it's quite a bit closer to the 400-yard mark, the normal 400-yard mark. It's closer to that mark than it is to the 300-yard mark, because we're dealing in a percentage of the overall distance from the muzzle of your rifle. So it's something you need to think about. Really, when you're at 400 yards, you could be at a pretty extreme angle, and you're not going to be off very far on your aiming point. Okay, so I've changed the lines now. They represent a 20-degree angle at each yardage, and you can see that that has really brought the lines closer to your standard marker there for each distance. So we're only cutting the angle by 10 degrees, but the difference there is about half of what you would normally have to adjust for a 30-degree angle. So it makes a big difference just between 20 degrees and 30 degrees on how far you need to pull away from your standard distance marker there. Okay, and now these lines represent a 10-degree angle, and you can see now that at a 10-degree angle you're only off by a click or two on each of these yardages. So you don't really need to make too much of a change if you're inside 10 degrees, either pointing uphill or downhill. It's not going to really affect things too much. It's when you get to the bigger angles like 30 degrees, 40 degrees, that's when you really need to make an adjustment. Now let's talk about what you need to do to adjust for environmental conditions like the temperature or the altitude or the barometric pressure. Up near the upper right hand corner of your chart, you're going to see this formula, and what you want to do is actually adjust your distance to the target. So the easiest way to adjust for these kind of changes is to add or subtract yards to your distance to your target. So you end up with an adjusted distance that you need to compensate for. Okay, if the temperature is higher, then your bullet is going to fly flatter. You're going to hit higher on your target. Conversely, if the temperature is lower, your bullet is going to impact the target at a lower position. You're going to have more drop at a lower temperature, and there's a couple reasons for this. First of all, if the temperature is hotter, it's going to make your powder more energetic, and it's going to make your bullet fly faster out of the muzzle. Your muzzle velocity is going to be higher. And another reason is because when the temperature goes up, the pressure, the barometric pressure, decreases as temperature goes up. So because the pressure is decreased, then that allows less resistance on your bullet. So your bullet can fly faster over the entire course of the distance because of the lower pressure, the lower air pressure. So when the temperature is higher, your bullet is going to fly flatter. Okay, now we look at our formula again, It says for a 30-degree temperature change, and then if we look further down, it says plus or minus 2 yards for each 100 yard. What that means is, let's say that you have a 30-degree drop in temperature. Well, that's going to mean that your bullet is going to fly less efficiently. There's going to be more drop because the temperature is lower. So you are going to have to add more distance. You're going to have to pretend like your target is further away because you're going to have to raise your muzzle of your rifle. You're going to have to raise your scope to compensate because the temperature is lower. So if there's a 30-degree drop in temperature, you're going to have to add 2 yards for each 100 yards. So let's say you're shooting at 700 yards, you're going to have to add 14 yards to your distance that you get on your rangefinder to compensate for the drop in the temperature. Okay, so we talked just now about lower pressure, but what do you do if you have a change in your barometric pressure, but there's no corresponding change to the temperature? Your temperature is still similar to what you normally would encounter. So if we look at our formula here, it says 1.5 inches of pressure is equal to plus or minus 2 yards for each 100 yards. So let's say your pressure decreases by 1.5 inches, then once again your bullet is going to be shooting flatter than standard, so you need to subtract distance from your standard range estimation. So if your target is 700 yards away and you have a decrease of 1.5 inches of barometric pressure, then you need to subtract 2 yards for each 100 yards. So at 700 yards, you need to subtract 14 yards. So you're going to end up at 686 yards instead of your standard 700 yard distance. Okay, now if you have a higher altitude situation, let's say you move to a higher altitude, that also means your bullet is going to fly flatter because you have less pressure. It's the same type of situation as decreasing your barometric pressure. So if you move to higher altitude, your bullet is going to fly flatter. Okay, so if you look at your formula, it says that a 1,500 foot change is going to be equal to plus or minus 2 yards for each 100 yards. So let's say you move to a location that is 1,500 feet higher elevation than your standard location. You're going to need to subtract 2 yards for each 100 yards that you're shooting. So if you range your target at 700 yards, once again you're going to have to subtract 14 yards to have a perfect impact at that distance if you're at a altitude that is 1,500 feet higher than your standard altitude. Thank you for your interest in Instant Ballistics products.